Once again, good morning and welcome to our general mathematics class. Yesterday, we have learned about propositions, compound propositions, and you see, we simply build or construct sentences no matter whether they are true or false. But this morning, lesson 5.2 will be about truth tables. We need to construct truth tables to determine whether the statement is true or false. But in this lesson, we will deal more on symbols. On the next day, on Monday, we'll deal more on sentences and their truth values. So let's just first have them in symbols. To start, let us recite today's memory verse found in 1 John 1 verse 9. Our keyword is truth. If we claim to be without sin, we deceive ourselves and the truth is not in us. Your Invisibility boosters is to make an acronym for the word truth that will tell people that the Bible tells us the truth. So you make an acronym T, R, U, T, and H. Like for example, T, trust the Bible, for it is the truth book at all times. Then R, it's your turn, up to H. At the end of this class, we'll be able to determine the truth values of propositions. Now, here's a given scenario for your venture activity. Prepare your chat boxes to share your ideas with me. Here's the first conversation. Mira asked, Sam, what are you doing? Samantha said, I am reading books and eating peanuts. In reality, Samantha is reading books but not eating peanuts. Is she telling the truth? Share to me in the chat box. Is Samantha telling the truth? Yes or no? What do you think? Samantha said, I am reading books and eating peanuts. But in reality, Samantha is only reading books, but not eating peanuts. Is Samantha telling the truth? No. Oh, very good. Said no. Now, may I hear a reason why no? Can I hear from Erica? Why is Samantha not telling the truth?
Kuan man gud ma'am. And man gud ang gibutang, so pasabot dapat duha ka buok pero kay wala man siya nagkaon og peanuts, so motong wala, feeling na ako ma'am wala siya nagstorya sa tinuod.
Very good. That's an on point, I should say. That's a bullseye. Correct. It's an and, so both should be done. Let's go to conversation number 2. Sam, what are you doing? Samantha said, I am reading books or eating peanuts. In reality, Samantha is reading books but not eating peanuts. Is she telling the truth? In your chat boxes, tell me, is it a yes or a no? Is Samantha telling the truth? What's your point? Yes or no? May I hear from Kiara? Kiara Ashley? Or from Jana? Or another from Joff? Yes. Yes, Joff.
Ay, kanang ambot ng tama ni ma'am pero ang previous statement man daw kay I am reading books or eating peanuts. Since or man ang gigamit, so na ang reality man ma'am kay Samantha is reading books. So pwede ra isa ra ka book yang gibuhat. So I think na yes na ma'am.
Oh, very good. That's an on bullseye again. No, thank you for that, Joff. The last one, the last conversation. Sam, what are you doing? I am reading books or eating peanuts. In reality, Samantha is reading books and eating peanuts. Is she telling the truth? Why or why not? Anyone has an answer, feel free to unmute your microphones and you'll get another extra points. Is Samantha telling the truth? Anyone who'd like to give it a try? Jovelyn or Jewel? Those of Hershey and Carl and Neil and Cherry. Who wants to answer? I am reading
No,
books. Okay, Carl. Go, Carl.
no, ma'am.
Go. What's your answer, Carl?
No, ma'am. Kay ang reality, ma'am, is si Samantha kay ga read siya books and at the same time ga count po siya peanuts. While ang iyang gi-answer kang Miro, ma'am, is na may or. So, dapat po end ni siya po, ma'am.
Another, we have heard from a no. Let us hear somebody who will defend for a yes. Anyone? No one? So you all agreed it's a no. Okay, now let me give my explanation to this. Conversation number 1 from Erica. It's a no. Why? It says I am reading books and eating peanuts. But in reality, both are not done. So Samantha is not telling the truth. In the second conversation, Sam said, I am reading books or eating peanuts. Only one is done. It's an or, so acceptable. She's telling the truth. In conversation number 3, I am reading books or eating peanuts. In reality, Sam is doing both. Here, if it is an inclusive and an exclusive disjunction, then only one should be done. But if it's an inclusive disjunction, doing one is just okay. So if I do both, it's very okay. So Carl has a point for one type of disjunction, but for the other type of disjunction, it can also be a truth. Now, I'm giving you 5 extra points for today's class. Thank you for participating. Now, let's have our discussion. What is a truth table? A truth table, it displays the relationship between the possible truth values of the proposition. Now, we have different truth tables for every type of compound proposition. Let's start with conjunction. Remember, this is the baliktad ng V, it's a hat for the conjunction. The conjunction, because it's an and, is only true when both P and Q are true. Remember, reading and eating peanuts. It's only true if both are true. If we see here, P stands for the first proposition, like Sam is reading books. Q is for the second proposition, Sam is eating peanuts. So if Sam is doing both, then P and Q is true. But if Sam is only reading books but not eating peanuts, it's a false. If Sam is not reading books and not only eating peanuts, it's still a false. And if Sam is not doing both, it's a false. So first point, For conjunction, it will only be true if both are true. Second, we have the inclusive disjunction. For the inclusive disjunction, it's the normal thing that we see. If it's not specified, then we just treat it as inclusive disjunction. So we go back to the rule. What's the rule? An inclusive disjunction is true if there's one that is true. At least one is true. It's false if both are false. Example, Sam said, I am eating peanuts, reading books and eating peanuts. Give me a moment, please. Let me use my pen. The reading books and the eating peanuts. Let's start. If Sam is not doing both, then it's a false. If Sam is not reading but eating peanuts, it's a true. If Sam is reading books but not eating peanuts, it's a true. Remember the conversation number 3? If Sam is reading books and eating peanuts, it's still a truth. Why? Because in inclusive disjunction, if at least one proposition is true, then the final statement is true. Let's go to the other one. In exclusive disjunction, you will see this symbol. There is, it looks like an equal to at the bottom, right? In exclusive disjunction, it says specifically only one should be done because it's an or. So example, reading books only, true. Eating peanuts only, true. Not doing both, false. And if you're doing both and it's an or, it's a false. But again, if it's not specified, it's automatically an inclusive disjunction. The third one, it's the simplest, it's the easiest, I must say, the negation. The negation is the opposite of the truth values. So example, the opposite of true, false. The opposite of false, true. The next one, conditional. A conditional is only false. You just look at the false. The conditional is only false if the P is true and the F. If the P is true and the consequent is false. Example, here's my statement. I will, if I will pass the test, then I will eat ice cream. Here's my statement. If I will pass the test, then I will eat ice cream. Now here, if I pass the test and I ate ice cream, that's a true. If I pass the test, but I did not eat ice cream, that becomes a false. Next, if I failed the test, I did not pass the test, and still I'm eating ice cream, it's a true. Why it's a truth? Because it's possible that there are some reasons that I'm eating ice cream, not only passing the test. If I did not pass the test and I ate ice cream, then I did not eat ice cream, that it's still a truth. Here, let me highlight the false. I told you that if I'll pass the test, I should eat ice cream, but I did not. Therefore, it's a lie. Questions? In the last one, the biconditional, it's only true if both have the same truth values. Example, Both are true. That's true. Both are false. That is still true. But if one has a different truth values, then these are false. Let's have a very brief review. Conjunction. It's true when both are true. Inclusive disjunction. One should be true. And exclusive disjunction, only one should be exactly true. For negation, the opposite. For conditional, it's only false when P is true, but the then part is false. In biconditional, both must have the same truth values for it to become true. Now, how do you construct truth tables? We start with simple statements, like you start first with proposition P. P should be in the pattern true, true, false, false. The second proposition, or your Q, should be in the pattern true, false, TF, TF. You see they have different patterns, right? Then we add more columns for other connectives. And the last column must have your last statement. Example. Here, we are going to construct a table for P or not Q. So I have P here, I have Q. Next, negation, not Q. And the last column is for the complete statement, P or not Q. You notice in our P column, it's true, true, false, false pattern. In your Q column, that's true, false pattern. Now, let's start with the negation of Q. You look at the Q. It's true, so make it false. It's false, make it true. True, make it false. False, make it true. Next, P or, that's an or, P or not Q. You only look at the P and not Q column. This is an or. So what's the rule? At least one true to make it true. So here, true and false, there's one true, so true. True and true, true. False and false, no truth, false. And the last, false and truth, that is true. This is our complete truth table now. Questions? Feel free to unmute yourself or to raise your hand. Let's go to the second one. I only have five examples. In the next one, we have Q and not P or Q. So we can make it here. We can start with P or Q, the one inside the parentheses. Then we go outside, not P or Q. Then the last, Q and not P or Q. Here, don't worry. In your quiz, I've given the headings. You just need to fill out the one inside. So let's start. P or Q. This is an or, so at least one is truth. So true, true, true. True, false, true. False, true, true. False, false, false. Next. From here, you negate it. So negate the third column. You have false, 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 true. Here, that's the pairing. The last one, Q, this is the first one. Q and not P or Q. This is an and. So it means both must be true to make it true. So true and false, false. False and false, false. True and false, false. False and true, false. Any questions? I hope you can still follow with me. Let's go to the third problem. Okay, I'll make a heading here, not Q, and the other is the last, P, then not Q. Okay, not Q. Negate it, the opposite. True becomes false. False becomes true. True becomes false. And false becomes true. Next, P, then not Q. It's a then, right? It's only false when T, then F. Number 1, T, then F, false. Next, true, then true, true. False, then false, true. False, then true, true. Any questions? No questions? I'll go to exercise number 4. Now we construct the truth table for not P, biconditional, not Q. So make a not Q here. The last one is P biconditional, not Q. It's only the easiest is the not, the negation. So let's make it not P. So false, false, true, true. You just negate this. Next, not Q. Okay, negate this once. False, true, false, true. The last, biconditional of these two columns. Remember the rule for biconditional? It's only true if both are true or both are false. So the first one, both are false, true. The second, not the same, false. The third, not the same, false. The last one, the same, so it is true. Questions? No questions? I'll go to the next example. Okay, the last one. It's a long table. Construct a table for P then Q. It's here. Biconditional, not P, it's here. And or, not or Q. And then the last one is the final statement. Let's start with not P. Okay, here, negate it. False, false, true, true. Next, P then Q. Remember, it's only false if it's true, then false. So true, true, true. True, false, false. False, true, true. False, false, true. Next. Here, not P, this one, or Q. Not P or Q. What's the rule for or? At least one is true. So true, false, true. False, false, false. Both are true, true. One is true, so True. Next, the last one. This one and this one in biconditional. Remember the rule in biconditional? Both must be true or both must be false to get a true value. Both are true, true. Both are false, true. Both are true, true.
True.
Both are true,
True.
true. Very good. That's it. So, do you have any other questions? No questions? I hope you're learning